Yeah, yeah. We were playing the game. I won with like 500 ping. 500 ping. Weird. You should do like a.
I don't have Black Ops. I don't have the new backpack.
Oh,
I'm not gonna get it.
Alright.
Black Battlefield is coming out.
That's
in
the
a couple
game
days. So
I'm gonna be grinding that game out. I just know it.
I'm gonna grind it out until.
You guys want to play FFA Cruise over there?
You know, like Standoff, Newtown. I have all the other backpacks except for the new one. I just kind of like, I don't play Black Ops as much.
We should try getting some more. We should try getting a whole lot of people in our school who have a PS4. We could play Michael Myers. Dude, that would be fun.
I was playing Rainbow Six Siege after you rage quitted. I mean, 2 new friends and we won like 2 games.
So one game that Doers play, I want that game.
For honor.
I want it.
Get the beta so you can play it.
I don't know how to.
Just go on their website and just sign up, and then you'll get an email and say if you're accepted to play the beta.
Can I do it right now?
Yeah. You got free time until you come in here.
What's it called? Just
type it for honor and then show the website.
shop. Come on here.
It will be within 4 to 5 days. I got accepted
For honor beta.
Who's your phone? Who's your phone? Okay. For honor beta. See this one? Beta registration right here. And the rest. Yeah.
I want to play it.
Wait.
So if I can get a friend.
It's gonna take 4 to 5 days. You have to get accepted because it's really easy. Yep.
Hey, Alex, you want a remix tonight?
Of course.
You rock it with me?
That's Blizzard.
I know. You know, I didn't even know you rage quit.
I can do it.
Do you have any Uplay? Uplay account?
Wait, Alex, did Cole make you type in Uber?
No. All you have to do is type in the honor beta.
Oh, no. Like, if you
Okay, today, what we're going to do is we're going to do a couple notes here.
send that to me.
We're going to do a couple notes on not solving equations. We're going to be doing it on the sequences like we started yesterday. So have your notes out. We're going to do a couple sequences here today. Then remember, tomorrow you have your homework due. That was at page 38, 39. If you need time for that today, you will get some time. But that'll be after lunch. But right now we're going to do a couple sequences to make sure that you know how it works. So let's discuss all the parts of the sequence that we started yesterday. So we're on section 2.3, which is sets of numbers. Now the big topic. Now obviously we were talking about, we talked about prime versus composite yesterday. Prime numbers, you can only break it up to like 1 in the number itself, versus composite has multiple factors underneath it other than just the main 2. But what we're talking about today is a sequence. Now there's 2 types of sequences. We're going to discuss that today. Sequence, the big idea is, the process for actually finding a sequence. So the vocab terms we're going to talk about, we're going to talk about terms. That is actually a word that we're going to discuss. Underneath that, there's the initial term, and then the other main term that or word that we're going to talk about is the common difference. So this is kind of our goal today. We're going to do a ton of examples of sequences where you get comfortable with it. I try to make you have, it's kind of a challenge where you have to kind of find it. I think of these, they're like puzzles. You have to try to solve or figure out where the next couple terms are going to come from. So it's going to take some serious thought process. You might even need a calculator at some point today. And I think these are just fun. They're a good change of pace for us. We don't have to do so much homework where we can actually kind of enjoy these types of problems. Okay? All right. So let's jump in. Let's try a couple. Let's start with what a sequence is, right? A sequence. And I had this on the board yesterday. sequence is a list of numbers. A list of numbers in a particular order. Now that order can be anything. It doesn't have to go least to greatest. So notice I didn't write the word set. I know it is a set, where they have curly braces and stuff. But the big idea is that, when most people think of a set, they think of like a roster method where it has to go least to greatest. We're not going to be doing that. Okay, we're still using the curly brace and commas to separate numbers, but it's not roster method, not least to greatest. So let me give you an example like what we discussed yesterday. This is a sequence, right? Numbers are in a particular order, and the goal is to find what the next 3 terms are. So right now, when you're looking at this, that is a set. It's got curly braces. It's got separated by commas. It just happens to be in a roster method. It's least to greatest. But these are individual terms. It's the actual numbers that we're looking at. So a term, right? But the first one, we have a special name for it. Okay? The first number is called the initial term. That's your first number in the sequence. Then after that, we have the second term, third term, fourth term. I want the next 3. These numbers that are going to be back here. Now obviously it keeps going, right? It has the dot, These could go up towards the direction of positive infinity. What will be the next couple numbers?
First one's going to be 23.
23? Okay.
And 29.
29. I don't think 29. I agree with the 23 then. I agree with 23.
I know the order that's going in
Okay.
because like the 3 to 5 that's 2.
Okay.
5 to 8 that's 3.
All right, so what you're looking at is the gap. That's the common difference number. So he looked at, okay, it went up by 2, right? It went plus 2, plus 3. Then what would this do? Plus 4, plus 5, right? So what the next number was? Plus 6. Well, you're right? So plus 6, you take 17 out of 6, you get 23. What will the next gap be?
7.
Plus 7. So what's 23 plus 7? Ah, there's the next number. You're so close. All right, and then the next one after that?
38.
Yeah, 38. All right, do you see how easy this is when you can look at the common difference, the gap between numbers? That gap makes it so much easier. That, what you're looking at right there, that's a common difference right here. These numbers. The common difference can actually break apart the pattern. So how you're doing that. Okay, what you're looking at here, this is a typical sequence. It's a normal sequence. There's a pattern there, you notice it. Most people can figure out the pattern by using that common difference. That is different than this. This sequence is obviously way, way easier. So what's the next 3 numbers? And those are the next 3. Why? Because on this particular problem, the common difference was the same number every time. Plus 1, plus 1, plus 1, plus 1. What you're looking at here, when the common difference stays the same the whole time, not just the pattern, but like the same digit every single time. So they added 1 every time, or maybe they added 6 every time. When it's written like this is called an arithmetic sequence. Most people can figure out an arithmetic sequence in the first couple seconds.
8:15 is going to be the.
Yeah.
We're going to contact a few more.
Okay.
Like,
How many do we have? we have
we're gonna
3
try
or
for like
more,
6.
yeah, if we have 3 or more, we'll be fine.
Okay, and then the
More the better.
convertibles, I think we'll be fine on.
We have
We'll try-
6.
We'll try and, well, not yet, but we'll find out by the end of the day.
Okay. Alright, you're getting me worried.
No, I'm not.
Yeah, I am. Alright, so, alright, arithmetic sequence. The net gap number is the same digit every time. But now, here's the weird part. It has to be adding when it's an arithmetic sequence. It has to be add a number. It can't be multiplying by 4. Because I think yesterday we did that one example where I think they did something like this. I don't know if this is the problem that we had yesterday. Let me put it up here. I don't know if this was the number that we had. But this sequence is most definitely not arithmetic. Would you agree? It's not adding the same digit every single time. It's not, just adding 1 every single time. You can tell that right away. You can tell that in the first 2 numbers. The first, after the initial thing, you can figure out that it's not arithmetic. Because this went up by 3, and then it went up by 6. So right there, boom. It's automatically just a normal, it's a typical sequence. That's what we call it. It's not arithmetic, it's just a sequence. So there is a difference there. When the gaps are different, this type versus when they're all the same, then it's arithmetic. Okay, but there is a pattern. And I believe yesterday, I think Sean, you found it right away. Okay. So can anyone see what the pattern is? What is it? Yeah.
Oh, okay, so I'm just gonna start at 48.
Okay.
You're just adding it on.
Yeah. You just take 48 and add it to itself, right? So you take 48 and you add 48. That's what we did here. I took 3, add it to itself. Take 6, add it to itself. Take 12, add it to itself. 24, add it to itself. 48, add it to itself. I think that's a 96. 48 equals 48. I knew right now. 6, 1, that's a 96. All right. So we're good there. Then 96 going up. So 96 plus 96. 12, 31, that's 10, 19, 92. And then you add it again. And that's even further. All right. But you see the pattern there? In fact, when I made this, I didn't even use that. I didn't even think about adding it to itself. What I did is I just took it down 2. That's what I did. I took the 3 and multiplied by 2. Took 6, multiplied by 2. Took 12, multiplied by 2. 48 or 24 multiplied by 2. 48 multiplied by 2. 192 multiplied by 2. Yeah, so it's just that's how I thought of it. But if you look at the common difference, you can see patterns. You don't need to think about how I created it. You know what the next numbers are. Okay? All right, so do we feel comfortable with a sequence versus arithmetic? Arithmetic, you usually spot the first 10 seconds you look at it. You can just kind of see the pattern. All right, let's try a new problem. I'm going to give you one, and I want to see if you can figure it out. So this is one that I don't want anyone to say out loud. I'm going to give you 3 minutes here, and let's see if we can figure it out before we go to lunch. Okay? So here it is. So can somebody give me a starting number, please?
5.
5? You guys both say the same number.
I think so.
Yeah. 5. That was so weird. Still freaks me out when I said that.
So this is the one that's you just did over there.
So you've already recognized it, right? It's not arithmetic. Agreed? Because they're not jumping about the same gap every time. Suddenly the numbers got big really quick. So what your goal is to figure out the next 3. Now, obviously, you already know this is just a sequence. It's not arithmetic. It's just a typical sequence. They're in a particular order, but I need the next 3 terms. So this is where you might need to go borrow a calculator from you. They're in that little white thing that comes there from you. Okay. So Paul, if you want to bring that. Okay, so we're just in the middle of the classroom, so if people want to borrow that. So our goal here is to solve this before we go to lunch. We have lunch in about 5 minutes. So I'm going to give you about 3. Just the last one. The rest of the numbers are correct. That was actually that's really impressive. Found that out in less than a minute. I'm impressed. Fully impressed by that.
Oh, I see what I did wrong.
Figured you figured it out real quick. Alright, that's good. If anyone else has it and they think they want to share it, I want to look at it. Don't say I don't want it. Yeah, you got it. Yeah, good. Nice. Now, the fun part will be to see what your strategies were. Because every strategy is different. I can tell you what I did, and I can see what you did. That's the fun part. See how you even approach the problem. No.
Hey, I'm getting close.
You were close.
Which one was the closest?
I'm not gonna say it.
Mm-hmm.
Less than 30 seconds here, and then I'm going to talk about some of those strategies that people think they have. If you're onto it, I might give you a little more time. But you can get it. Okay, so Alex, you were the first one to come up with the first couple numbers. So I want to know, what was your strategy that you thought of when you first started this problem?
Okay, so when I first started the problem,
Yes.
I just checked the gaps.
Okay, so what was the gaps? Did you write it down?
No.
Okay.
What I did after that, after I checked the gaps, I just started minusing, like, say, 65 minus 33 was 32. And then I did 33 minus 17, and I got 16. And then I just did 65 plus 64.
Okay, so say it again. So how are you doing this?
Okay. I just minus it by like one behind it. So 65 minus 33, I got 32. Yeah. And I just went over here and I just did 64 plus 69.
Oh, so you always subtracted, and then you added.
Yeah.
Okay, so very close. In fact, the gap actually gives it away. If you look at the gaps, they're 4, 8, 16, 32. Those numbers are doubling every single time. So 4 doubles to 8, doubles to 16, doubles to 32. So the next one, you're right, was 64. So that would be the next gap. The 32 was double. So you get this, and you get your next number, so 65 plus 64, right? It's going to be a 9, and then it'll be 129. And then you do the same thing. So I add again. Well, I'm doubling the 64, which is 128. You're going to add that to this. So 129 plus 128. And when you add straight down, it's 1, 5, 2, 257. And then you do it again. So if I double 128, you get 256. And you add that. So 257 plus 256. And you add this 3, 1, 11, 1, 5, 3. You added one now.
Yeah.
Okay. So these are the next three. Now, here's the crazy part. Okay. So Hannah, did you come up with that same strategy? Okay, so I want to hear, what was your way of doing this?
I did 5 plus 5 and I subtracted by 1.
Okay. Yep. That's the pattern I did. Yep. You add the number together you take 5, you add it to itself, subtract 1. Add 9 to itself, which is 18, subtract 1. 17 plus 17 is 34, subtract 1. 33 plus 33 is 66, subtract 1. That's 18. That's how I did it every single time. It's doubling the number, subtracting 1. Doubling the number, subtracting 1. That's how I create it. But the gap gives it away. You see the strategy here. There's completely different ways of thinking about these problems. The gap will never lie to you. The gap will always work, that common difference gap. Okay, let's go to lunch. When we come back, we're going to try some new ones.
Gaps don't lie.
Gaps don't lie. They will always work.
I like the dips.
Get in here. Alex, tonight's gonna be a good night for me.
Okay, hey, we'll start here in a minute. So. Okay. All right, let's start writing in on this. All right, so before we went to lunch, we talked about this one, right? That there's different strategies. If you looked at the common difference, the gap between numbers, you can definitely see the pattern, as long as you understand how those numbers are working, like the 4, the 8, the 16. That's where your calculator would be handy. The gap between numbers will pretty much always help you out. That's just what you need to realize. Now, I'm going to try to come up with a number that will be difficult, something that you might have to think about. Okay? So I'm going to give you one more sequence here, and I'm going to see if you guys can figure these out. I might actually give you 2, because I got a couple others in my head that I want you to see if you can try. All right, so here we go. This one. I'm interested to see how well people do. Goal is to find the next 3. Now, before we start, is this an arithmetic or just a typical sequence? Typical. Why? Yeah, it's just not consistent, right? It's not like, oh, they're adding 2 every time, or adding 4 every time. There's different numbers there. There's different gaps. Okay, your goal is to see if you can find the next 3. Okay, so if you need calculators, they're behind. I think they're right here. So, you need calculators, here you go. good. Really close.
Here's mine.
You were really close.
Right there. Is any of them close or right?
Nope.
Oh.
Once you see the pattern, oh my gosh, I cannot believe I didn't see that. I'll give you another 2 minutes. 2 minutes. If you guys feel up to it, I'll give you your last one. Actually, our homework this week will be finding common differences, finding gaps, finding next to read.
I just confused myself.
I'll be quite impressed if somebody actually figures this out. One of the more challenging sequences we have.
I'm gonna show you what I got.
I'll watch.
So you actually nailed it. Impressive. I hope I did.
You did. That's impressive.
I did. Hope. Congratulations.
I don't remember what I got now. Mine's close. My math might be off. Might have been
Well, maybe my math's off. Okay, let's go through this. What you're looking at here is probably one of the most famous sequences in the world. It's called the Fibonacci sequence. It's actually a sequence that happens in nature. Sunflower seeds. This is how sunflower seeds grow on a sunflower. Okay, so if you have a sunflower, you have the petals around it. If you've ever seen one, there's actually, if you've ever seen a sunflower, there's actually one right on the state street. There's a house that actually grows them right on the side of their house. The seeds in the middle grow in this pattern. And they bunch together, so when you look at the seeds, they actually bunch and they spiral outwards. So it goes one, there's 2, there's 3 seeds, 5 seeds, 8 seeds. And how you know there's going to be a little gap between them. That's how you know they spiral outwards. Snail shells or hermit crab shells, when they grow in nature, and you look at the actual shell itself, right, it has this, there's hash marks that go in this pattern on the actual shell. It's the weirdest thing you'll ever see when you first see it, right? So, there's little hash marks, and it actually grows in this Fibonacci sequence. Now, how the sequence works, and it's actually the way the numbers are created and why this actually happens in nature, okay? Going from here to here, adding 0, here to here, adding 1, here to here, adding 1, here to here, adding 2, here to here, adding 3, here to here, adding 5, which which is the weirdest thing, right? Most people think, oh, they're going to add 4. No, they add 5. Well, that's weird. Until you see the pattern and how it's creating numbers. And once you see it, you're like, oh my goodness, that is easy. How I'm creating the numbers. To make this number right here, you always add the 2 that are directly behind it. That's how the pattern works. So, to make this number, you add the 2 numbers that are directly behind it. So, to find the 5, guess what numbers I add together? 3. You always add the 2 numbers behind it. So, to make 8, you always add the 2 numbers behind it. To make 13, the 2 numbers behind it. So, to get the next number in the sequence, you add the 2 that were there. What do you want?
But that's what you got, right?
It still works. Then, you get to the next number in the sequence. So, to get this next number, you have to add these 2 together, which is 34. Then, to get to the next number, you add these 2.
Oh, yeah.
So, it does work. Now, there's other strategies that people have. You know, they notice, like, they notice the pattern, how it's working, how, like, the gaps between these are always going up and stuff. But if you just notice from the pattern from the beginning, how it's making each number, it's pretty straightforward. Okay? It's actually using previous numbers, which is kind of, and that's why the actual like sunflower seeds work that way. It uses the previous seed to make the next 2 seeds, and it uses those 2 seeds to make the next couple seeds, and that's why they grow in this pattern. Same with the shell. The shell spirals, and the marks that are being made are affected by the marks that were previously made. So that's the way it works. So just kind of an interesting little thing. Okay, by far the most famous sequence. And, I mean, they have it in movies, they have it in books. I mean, it's just kind of a cool sequence. Obviously, it's not arithmetic because it's the gap. Obviously, you can tell my gaps they were changing. You know, 1, 1, 2, 3. So the gaps are changing. So it's not arithmetic. Okay. Do you want to try one more today?
Yeah.
Okay. One more little challenge. Let's see if you guys can do this. This is good. The fact we even had one person in this room figure it out. That is most definitely impressive. Ms. Mitchell, did you figure it out?
No, mine's wrong.
All right.
But that
So,
looked very familiar to me. I was like, I know that from somewhere, but I just didn't put it together. with
If
the
you've read
Fibonacci.
Dan Brown books like, let's see, Angels and Demons, or Da Vinci Code, or The Digital Fortress, like those books, he's one of my favorite authors. He uses a lot in his books, and he actually ties it in with different things, which I think is really clever. All right. So the next sequence. This is a little bit easier. It's not as crazy difficult as the previous one, but I want to see how I do. There's two definitive strategies for this one. This is a good. I think it's a good one to end on today. It's a good, easier one. Not as hard as challenging as the Fibonacci sequence.
Pattern.
This one is not as hard, so it should definitely be doable. Got it.
Moving on, man.
I got it.
Got it. All right. Is it a typical sequence or arithmetic?
That one, though.
Typical sequence, just it's a regular sequence. You know, the gaps are definitely different. Okay. All right. So Cole, you think you got it?
Yeah.
Okay. What's the next number going to be?
49.
I agree. Okay. Now, here's my question to everyone else. Did everyone get 49? That is correct. Okay. Okay. Didn't get 49. Were you at least close?
No.
Oh. Okay. Okay. Somebody else that maybe had that. What was your next number?
My next number was 64.
Is that correct?
Yep.
Okay. That is right. Now you're probably wondering, how is that possible? We'll see. Last one?
81.
81. I agree. Those are good. Nice. So, okay, we had 3 different people that at least got the answers. Did somebody else get these? Well, yes, no? Okay, that's what you're having. All right, so, all right. Okay, now, here's the thing. What was your strategy? So, Cole, you were the first one. What was your plan that you did on this problem?
First, I just did the gap.
Okay, so what were your gaps here?
And so I got 3, the first one.
Yep.
Then 5,
Okay.
and then 7,
Okay.
and then 9.
Okay. So, what are you noticing so far?
They all went up like 2.
Yeah. The gaps are going up by 2s every time. Okay. It's not arithmetic sequence. Even though it looks like the gap's going up by 2s, what arithmetic means is it means the gap would be the same number every time. So that instead of going plus 3, plus 5, plus 7, it'd be plus 3, plus 3, plus 3, plus 3, plus 3. That'd be arithmetic. That'd be too easy. This definitely had something, because obviously everyone can get it right away. So it went up by different numbers. It's going up by odd numbers, which is the way it works. So the next number you'd add 13 to it, making that 49. Then going up, instead of 13, now you're going up by 15. Then going up by 17. So that's the idea. And that's how you get those numbers. Okay? So that is the main strategy. Now, here's the crazy part. I didn't make it with those. That's not how I made those numbers. It does work, because the gaps will never reply to you. They will always be correct numbers. But how I did this. Look at the first number in the sequence.
Oh, I think I see what you did.
Number 1, right? 1 is made from 1 times 1.
Oh, I know what you did. Yep.
4 is made from 2 times 2. 9 is made from 3 times 3. 4 times 4. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 9 times 9. So the next number would be 10 times 10, which is 100. And you keep going. You notice I'm not using like gaps. Or I'm adding 19 or whatnot. I just chose those numbers. This typical sequence is the square number sequence. So these are the squares. That's what they call them, the square sequence. Okay? As opposed to the last one, which is the Fibonacci. Hopefully that spelling is correct. All right. Questions, comments about these? Now, obviously, the ones I've given you these last few have been challenging. I know they have. Okay, but I I wanted to let you see like my strategies. The gap will not lie. It works every single time as long as you see the pattern there. Even seeing that strategy where the gap was going up by 2. So, but tomorrow we'll try a couple more of these. You'll probably have an assignment tomorrow on this stuff. Okay. I know tomorrow's our last day of the week for us because we won't have class on Friday in here. So the homework will be due next week. It won't be due tomorrow. Okay. But it's based on this stuff, so you gotta get pretty good at it overnight. Okay. There's gonna be some tough ones, and there'll be some ones that it's gonna make you think for a while.
So, Mr. Ward, so it's gonna not be like really hard to find out or figure out.
So at first, when you don't know the pattern, it's one of those it's a challenge. It's a challenge to see that.
I'm great at diagram.
Yeah, I'm impressed. That's good. Very good.
When people walk by in the hallway and look at me and giggle.
Really?
Good. Very funny.
So what is this?
Chess.
No way.
Yes.
It's a game.
It's
Squares.
not going game.
You move one piece at a time. Each piece has their own moves. And the
Wait,
point
can
is
everybody
after
move
the
it?
game.
Mr. Ward,
No,
can
He's
anybody
the one with the
He's got a game going.
cross.
Somebody.
So once you capture the fingers, put him in a position where he can't move. He'll be captured by the other piece. Then you want to say checkmate. So that's the whole goal.
Wait, who's playing? Like,
I am playing